Similar to free radical initiators, there are cationic initiators. For example, strong Lewis acids, electron acceptors. They act as cationic initiators. Such strong Lewis acids in the presence of small amount of water reacts to give H plus ion. This H plus ion, this cationic species, is in the vicinity of this counter ion. Therefore, this counter ion is not taken into consideration. For example, the equilibrium constant for the formation of cationic species from the cationic initiators, where water is called co-catalyst. This is a catalyst, this is a co-catalyst. The equilibrium constant for this process, for this reaction step, is given as follows: K equal to concentration of H plus divided by concentration of ACl3, concentration of water. The counter ion is in the vicinity, is always in the proximity of ion, therefore it is not written. Therefore, the concentration of cationic species produced, the concentration of H plus ion, which initiates the cationic polymerization reaction, is equal to concentration of A into constant equilibrium constant into concentration of aluminum chloride and water. There are three steps involved in the mechanism of cationic addition polymerization reaction. The first step involves initiation, chain initiation. The cationic species formed attack the pi electron rich species, especially unsaturated alkenes with the electron rich substituents, electron rich or electron releasing substituents, so that it can attack the cationic species to form M plus. This is M, one monomer is there, therefore M plus. And in the propagation step, this M plus attacks another monomer to form M2 plus, and this M2 plus further attacks another monomer to form M3 plus, and M3 plus further attacks another monomer to form, and so on, Mn plus. That is, Mn plus is also equal to MnH plus is also equal to M plus. Simply it is generally represented as M plus. There are three types of termination steps involved in this polymerization. For example, the first one is the reaction of counter ion with Mn plus, that is MnH plus, to give Mn plus AlCl3, water is formed. In the second possibility, there is a combination, there is a strong combination of counter ion with the Mn plus polymer cation to give. In the third chain transfer, by chain transfer mechanism, H plus is transferred to thiol anion or NH2 amines, etc. Good morning. In this class, we will study about kinetics of cationic addition polymerization reaction. This is very similar to free radical addition polymerization reaction. So please watch the free radical addition polymerization. Okay, now let us see the mechanism. It involves the attack of cationic species, whereas in free radical reaction, free radical species attacks the monomer. Here, it involves the attack of cationic species on the pi electron pair of monomer. The cationic species are pi electron acceptors, whereas the monomers
or pi electron donors. Now let us see cationic initiators. Similar to free radical initiators, there are cationic initiators such as strong Lewis acids, BF3, AlCl3. They are electron poor, electron deficient, therefore they accept electron pairs, okay, with water as co-catalyst. Monomer, for example, unsaturated alkenes with possessing electron releasing substituents, for example, isobutylene. Electron releasing substituents are present. Such alkenes undergoes cationic addition polymerization reaction. Such alkenes only. Otherwise, for example, if there is electron cyanide group, then it is electron withdrawing group, then it will not undergo by this mechanism. There are 4 steps actually involved. Actually 3 steps, including cationic species, the formation of cationic species. Aluminum trichloride, cationic initiator, reacts with water in small quantities as co-catalyst to give this cationic species. The counterion is always associated. With the H plus ion. Therefore, it is not considered. It is not returned. The second step is initiation step. In the initiation step, the cationic species attack the pi electron pair of monomer to form MH plus. The rate of initiation is equal to Ka, concentration of monomer, into concentration of H plus. Okay. The next step is propagation, chain propagation step. In the chain propagation step, this MH plus, M1H plus will attach another monomer to give M2H plus and so on to give MnH plus. Okay. Therefore, M1H plus is written as Mn plus. In general, it is written as M1 plus, M2 plus, M plus. Okay. Therefore, the rate of propagation is equal to Kp, concentration of M plus, and the concentration of the monomer. Okay. The 4th step is called termination step. In the termination step, there are 3 different termination possibilities, termination reactions or possibilities. Let us see only here combination of MnH plus and the counterion. MnH plus, this combination of polymer cation and the counterion. And another possibility, the reaction between the polymer cation and the counterion to give back polymer plus AlCl3 and water. Okay. Therefore, the rate of termination is equal to termination rate constant into concentration of M plus. This is not considered because it is always in the proximity of MnH plus. Okay. Applying the steady state approximation. Let us apply the steady state approximation. Under steady state approximation, the rate of initiation is equal to rate of termination of cationic polymerization reaction. Therefore, Ka MH plus equal to K3 M plus. Okay. From this, the intermediate species, from this steady state approximation, the unstable intermediate species concentration is obtained. Okay. Therefore, the concentration of M plus equal to K by Kt, concentration of M, concentration of H plus. Next, the rate of overall cationic addition polymerization is equal to sum of initiation rate and the propagation rate. That is equal to, for one initiation there are n, M1, M2, there are n propagation steps. Therefore, the rate of propagation is always very much greater than Ri. Therefore, it is approximately equal to rate of propagation is Kp and M plus and M. Therefore, you can substitute M plus here. Okay, the concentration of M plus. Therefore, you will get m plus whole square and concentration of H plus. The overall rate of polymerization reaction is the order of the overall polymerization reaction is 3. 2 with respect to monomer concentration and 1 with respect to cationic species concentration. Okay. Now, what is kinetic chain length? The kinetic chain length is nothing but degree of polymerization. It is also equal to the average number of monomer present per polymer chain, present in the polymer chain. That is chain length. How many polymers are present in one chain, polymer chain? It is calculated from the ratio of rate of propagation to rate of termination. Rate of termination equal to rate of initiation. Okay, therefore Rp, you know, this is the Rp substitute, and Kt m plus, therefore Kp by Kt concentration of the monomer. In the exam, in the competitive exam, they will ask you to calculate the kinetic chain length or the degree of polymerization, providing Kp, Kt concentration of m. Okay, so thank you for watching.